Hey everybody, I'm going to take a little bit of time here today to give you an idea of an example type question that you're going to get on the quiz, which I'm giving on November 24th, 2021. So you will have a table that you see in front of you that has the Lewis dot structure. It has bond sides and lone pair sides. It has predict the shape, predict the molecular polarity, and finally predict the intermolecular forces. And based on the information that we learned about through the entire chapter, you should be able to identify all of these things, each worth 1 point. And you'll have 2 molecules to do. They're going to be different, obviously, and you will have to do these 5 things for 2 molecules for 10 total points. So I'm going to show you an example of how you will carry out something like this on the quiz coming up soon. So let's, for example, say I have the molecule NF3, and that's all I will give you, just the molecule NF3. And you want to first start with the Lewis dot structure. But before I can start with the Lewis dot structure, I should add up my valence electrons. So 5 valence electrons plus 3 fluorines, each of which are 7. 21 plus 5 is 26. So that's how I have NF3. So I can start with N and combine it with single bonds and subtract 2 electrons per bond, leaving me with 20 dots. So now I place the 20 dots working outside in. So here's the first 6, here's 12, here's 18, and finally 20. Now that Lewis dot structure is finished because I checked to make sure everything has 8 valence electrons around it, and there's no need for double bonds because the central atom has 2, 4, 6, and a pair makes 8. So now I go to the next part and I say how many sides of the central atom have bonds and how many sides have electron pairs. And when I look at it, I see 3 bonds around the nitrogen and I see 1 pair of dots. So it's lone pair, 1 pair. Not how many dots, it's how many pairs of dots. So the next thing I'm going to do is I snagged a screenshot of the shapes table from our notes, and I put it in right here into this area underneath the table just so I could show you what I'm looking at. So since I have 3 sides with bonds and 1 side with dots, well, the 3 and 1 is trigonal pyramidal. And so predict the shape, that's trigonal pyramidal. Next, we learn that certain shapes are always going to be polar and certain shapes are usually going to be nonpolar. Now, here is the picture of that from our notes. These shapes are always polar and these shapes are always nonpolar. And trigonal pyramidal is on the table that says polar molecules. So when it says predict the polarity of the molecule, in this spot you will write polar because a shape that's trigonal pyramidal will always be a polar molecule. Finally, I'm going to take another screenshot from another part of our notes that talks about how to predict the intermolecular forces. If you remember, I said if it's polar, it has the intermolecular force known as dipole-dipole, and it also has London forces because all things exhibit London forces. So since this is a polar molecule, then it has both London dispersion and dipole-dipole. Now, if you predict the molecular polarity to be nonpolar here, then you would only put London dispersion in this space over here on the far right. These 5 things are each worth 1 point, and you'll have to do this for 2 different molecules. This pretty much breaks down how you would answer each part and how you get points in this quiz. Anyway, that takes care of this little video. Thanks for watching.